Hello, today we are going to show the ratio theorem. And to do that, we need to introduce the triangle that defines what is it going to be about. So for example, here we have a triangle that is named the triangle OBA. And we see in the image that, well, the point B is defined with a position vector B, and then the point A is defined with a position vector A. And we have a point P that is dividing the segment BA in a proportion lambda mu, or in a ratio lambda mu, right? And this segment AB, well, it is divided by the vector P. Okay, so the vector P is pointing to the point P. Perfect. So to explain what does it mean to have a division by some ratio lambda mu, we need to notice that we can split the segment AB into two pieces. The first one is going to be AP, which can be represented by a vector, maybe AP like this, and then another one, which is the segment BP with the vector BP. Okay, so these two segments are going to be in a proportional relation with the whole segment AB. Like, for example, for AP, we are going to have that is equal to lambda divided by mu plus lambda AB, right? So it's like taking the percentage that corresponds to AP from AB, right? The piece from AB that corresponds to AP. And then for BP, we are going to have that it will be mu divided by mu plus lambda, and then times AB, right? But looking at here, we define like thinking that AB is pointing in this direction. Then we need to take a minus sign over here because a BP is pointing to the other direction, right? So this will be minus AB. Okay, perfect. So again, this is like taking the percentage of AB that corresponds to the segment BP, but in a vector way, and using the proportion that the image is giving us, lambda mu, right? So we are interested in finding the vector P that divides the segment AB in terms of AB, lambda, and mu. Okay, so just by looking to the image and using some basic algebra from vectors, we know that A plus the vector AP should be equal to P, right? And then again, from the image, we see that B plus BP is equal to P. Okay, perfect. So obviously we are interested in eliminating these vectors over here, so that they will be in terms of AV and AV using these relations that we found first. So for example, the first equation will be A plus AP, right? But AP is this. So it will be lambda divided by mu plus lambda AB equals to P. And then the second equation will be B plus mu divided by mu plus lambda times minus AB, and then this is equal to P. And we can take this minus sign outside here, and then see this like this. Perfect. So as you can see, we have two equations. I think it will be good to, for example, solve this equation for AB, and then take that result into this piece of here, so that we get an equation that only relates P, A, and B. So from this first equation, we can see that AB is equal to P minus A times mu plus lambda divided by lambda, right? And then this result can be set into this equation to get that B minus mu divided by mu plus lambda times mu plus lambda divided by lambda P minus A equals to P, right? So remember that our goal is to find P, the vector that divides the segment AB. So we may need to solve this equation for P, right? Okay, so after canceling these two terms, we get that b minus mu divided by lambda times p minus a equals to b, and this is equivalent to b minus mu p divided by lambda plus mu divided by lambda a equals 2p, so that multiplying this by lambda on the numerator and the denominator, we are going to get that 1 divided by lambda times lambda b plus mu a is equal to p plus mu divided by lambda p. Again, multiplying by lambda here and here, we get that this is equal to 1 divided by lambda times p times lambda plus mu, right? So comparing both sides of the equation, we see that we can cancel this 1 divided by lambda over here and over here to get that, well, p is equal to 1 divided by lambda plus mu times lambda b plus mu a. Perfect. And this is known as the ratio theorem, right? It's just like splitting on a certain proportion a segment AB from a triangle, right? So it is important to have this kind of images to see well what this equation means, right? So in principle, this equation does not have any meaning if we do not have the context of the image over here that explains us what is the proportion between AP and AB and between BP and AB, right? Perfect. So in another video, we'll see an example of how to use this ratio theorem, for example, to calculate the centroid of a triangle. Okay, so thank you so much for watching.